Let's do some examples that involve finding antiderivatives that use the power rule, the constant multiple rule, and the sum difference rule. All right, so let's start with this problem. We want to find the indefinite integral of 9x squared plus 7 minus 5x to the negative 2/3. Now, we just recently learned the power rule for antiderivatives, which tells us how to take the antiderivative of something like maybe x squared. So remember what that says is that sort of the opposite of doing a derivative. You add 1 to the power, so this would become x to the third, and then you divide by that power. And then if you're taking an indefinite integral, you always have to remember to add a plus c because antiderivatives come in families. Okay, so that's what we've learned. And then we also just recently saw the constant multiple rule, which tells us we can pull a constant multiple out front of the integral. And we also saw the sum rule, which tells us that we can break up sums and differences. So let's use those rules to find this antiderivative. So first, I'm just going to go ahead and split this up into parts based on the sum rule. So this tells me, the sum rule tells me this is equivalent to the integral of 9x squared dx plus the integral of 7 dx minus the integral of 5x to the negative 2/3 dx. And then, because of the constant multiple rule, I can pull all of these constants out front, which maybe just makes it a little easier to think about how to find the antiderivative. So I have 9 times the integral of x squared dx plus the integral of 7 dx minus 5 times the integral of x to the negative 2/3 dx. Now, each of these integrals is something that maybe we're a little more familiar with. So let's go ahead and take those. So we keep our 9. And now I want to write down the antiderivative of x squared. Well, we just wrote that over to the side, right? So that's going to be x cubed over 3. Okay. Now the antiderivative of 7. Okay, so you could apply the power rule here. Maybe it'd be a little strange to try and do that. So let's try to think about what this would be. The antiderivative of 7. Well, I'm trying to think of a function whose derivative is 7. Okay, so that's going to be 7x, right? The derivative of 7x is 7, plus a constant, but I'll just put my plus c at the end. So 7x there, minus 5, and then I've got x to the negative 2/3. So this is a fractional power, but I use the same idea. So I want to add 1 to the power. So negative 2/3 plus 1 is 1/3, and then I divide by that same power. And then I add my plus c. Okay? It's not necessary to add a plus c after every term because just a single plus c suffices, right? Plus 3 arbitrary constants can be written as plus 1 arbitrary constant. So plus c at the end is fine. So now we probably just want to clean this up a little bit. So I have 9x cubed over 3, so that's 3x cubed plus 7x. So I have minus 5 x to the 1/3, and I have this 1/3 in the bottom. So I can flip that, right? Dividing by a fraction is the same as multiplying by the reciprocal. So 5 times 3 is 15. So this is minus 15 x to the 1/3 plus c. And that is our answer. Okay, so this one was pretty straightforward, right? It was easy to see that we should use the power rule and these constant multiple and sum difference rules. Now sometimes you'll have an integral that initially looks pretty complicated, but just by rewriting it, you can use these same basic rules. So let me show you 2 quick examples like that. Okay, so first of all is something that looks like this. The integral of 3x to the 17 minus 5x to the negative 7 over x cubed dx. Okay, so when I look at this, just how it is now in its current form, it doesn't really initially appear that I can use any of the antiderivative rules I know so far, right? This is a quotient. And we haven't learned really how to take the antiderivative of quotients. We've just learned the power rule, and rules for multiples and sums. So, this is maybe a little strange looking, but if we just use a little bit of algebra to rewrite the problem to begin with, then we can use our familiar basic rules. Okay, so how can we rewrite this? Well, I have two terms in the numerator and they're over the single term in the denominator. And whenever you have multiple terms in the numerator, you can always split those up. Okay, so what I mean by that is I can write this as 3x to the 17 over x cubed minus 5x to the negative 7 over x cubed. Okay, so you can always split up the numerator like that. You can never split up the denominator if there's multiple terms in the denominator. Okay, dx. Okay, and now, this is nice, right? Because 3x to the 17th over x cubed, I can reduce that. That's going to be 3x to the 14th minus, I could write this as 5 over x to the 10th or 5x to the negative 10th. I'm going to write as 5x to the negative 10th to make it a little easier to see how to use the power rule in the next step. Okay, so basically we just split up this quotient and we were able to reduce it to these two terms that we can now use the same process as we used in number 1. So I'm going to start by splitting this up using the sum rule and the constant multiple rule. So I can write this as 3 integral of x to the 14th dx minus 5 integral of x to the negative 10th dx. And then I use a power rule on each of these terms. So 3 times x to the 15th over 15 minus 5 times x, and I'm adding 1, so that becomes negative 9 over negative 9 plus c. All right, and then let's just clean it up a little bit. So I have 3 over 15, that's 1/5, right? So x to the 15th over 5 minus, so notice here we have minus a negative. So I'm going to change that to plus. And there's a few different ways you could write this. Personally, I'm going to put that x to the negative 9 in the bottom, make it x to the 9th, but you could leave it as a numerator as x to the negative 9 if you prefer. But this is what we have as our final answer. Okay, I want to show you one more very quickly. So what if I have something that looks like this? Once again, initially, right, just looking at this, it doesn't look like anything we know how to take the antiderivative of. Right, we have a product, and right, so our simple power rules don't really apply to this yet. But just like I did with number 2, if I just use a little bit of algebra to rewrite this, I can use my power rule. And actually, this is a lot like when we learned to take derivatives, right? At the very beginning of taking the derivative, if I had asked you to take the derivative of this, you might have chosen to FOIL it out first. And that's what I'm going to do. So if I FOIL this out, I get x cubed minus 5x plus 7x squared minus 35. Okay, and then I can split that up. So integral of x cubed minus 5 integral of x. These should all have dx's. Plus 7 integral x squared minus the integral of 35. And then I just compute each of those individually. So this first one becomes x to the 4th over 4. Then I have minus 5 times x squared over 2 plus 7 times x cubed over 3 minus, the antiderivative of 35 is 35x plus c. Okay, and then there's not very much cleaning up to do here, so this is just our final answer.